All right. Hello, everyone. So today I'll be talking to you about pretty much how to build both mobile and web applications using single code and using Angular for it. And I dare to say that if you know Angular, you already know mobile. So I'm Sebastian Witalec. I work for Telerik, the creators of NativeScript. And if anyone is on Twitter, you can follow me as I'm Sebavita. It's pretty short, easy to remember. It doesn't take much characters either. All right. So first things first, why native? Like, why would you even bother writing native? I mean, you could build a mobile website, right? The thing is that native gives you this rich and performant experience, right? And like, if you look at some numbers, you can pretty much see that people spend about 18 times more time on the mobile applications that are written natively than websites. But the thing is that web itself has its own benefits as well, right? Web is very good when it comes to the reach, right? You don't have to have a specific device or specific model or specific operating system, right? You can actually reach much bigger audience. So like Luke Wróblewski said, pretty much, mobile is for the experience, web is for the reach. And it's not that you should be looking at the competitions like, is it web versus mobile? But it's actually, you need both, right? You have to have strategy to kind of aim for both. Or even desktop, right? Nobody should forget desktop. The thing is that as soon as you go for multiple platforms, you're looking at many issues, right? Like you got code fragmentation, you have to have different code bases, you have different set of issues, you have different set of skills, different IDs. It's just a lot of problems. So that's where pretty much NativeScript, Angular 2 comes in as the hero, right? Like, hey, we're here to solve your problems. So the thing is that Angular 2 itself has this platform-agnostic architecture, right? So the whole idea is that you can build your code at one point where it has nothing to do with the UI. It's about the business logic of what you're trying to achieve, right? And so that's the platform-agnostic part. And then when you want to deploy to a mobile application or a website, then there's a platform-specific code that kind of performs and translates your UI to what should be in the native, either mobile application or on the website. So let's look at an example. If you wanted to build a little login screen, right? So we'd start a small model. So you'd have a user with an email and a password as attributes. Then we'd have a service, right? So that service would take your user model, and you would have functions like register, login, or reset password, and something to handle the errors, right? The specifics are not important, but at this point still, we're writing code that doesn't say, hey, go grab this text field or grab this label and do something with it. It's just pure code base, pure logic. And then we start working with the components. So when you build a component, you go and import your service, and you provide as a provider. And then you inject it into the constructor. So then you can actually use the user service across the whole component. So that you can actually then go and use that service to call login or register a new user, right? And still, so far, there's nothing that actually says this is a mobile or a web application, right? And this is the beauty of Angular 2. So now we step into the territory where we actually have to define what goes in the UI. And this is where it actually differs, right? So in this case, this is a template to render on the website. So we have a couple of labels and input fields that are bound to our user email and user password. Then we have a couple of buttons, one for login and one for sign up. And that's actually where we actually say, OK, this is how my website should look like. So what do we do about mobile story? Well, that's where NativeScript comes in. And we openly say that we love Angular, and Angular loves NativeScript. That's obvious. And the thing is that we've been working with the Angular team for quite a while. So pretty much since May last year, Tobias Bosch, who's one of the lead developers on the Angular side, was meeting with Hristo Deshev every Tuesday. They had a hangout. And they were pretty much planning the mobile world domination, right? And I tell you, it's going good. It's going good. And from the very beginning, like, this is actually a screenshot from our Google documents. And very first meeting, it was like, OK, so how do we take this platform-agnostic architecture and turn it into mobile-friendly framework. So this is what we did. So we took the platform-agnostic part, and for the markup, we said, OK, we're going to use HTML. And as a DOM adapter, we're going to use parse5. And this is pretty much standard stuff. So parse5 allows us to compile the whole code into proto views. And this is pretty much what is needed to build those services and the components, right? But then when it comes to defining what goes in the HTML or what goes in the UI, that's where most of the work was happening on our side. So we had to implement this NativeScript renderer, which basically can generate a native visual tree. The cool thing about NativeScript renderer is this is the middleman who kind of propagates messaging from proto views to the native visual tree. Or if there's something that happens on the UI, this message has to go back to your Angular code. It's, again, the NativeScript renderer that takes that message, passes it to the proto views, and then something happens. So basically, all that means that you can write code like this. So one of the examples is we didn't have a checkbox on a mobile application. You have sliders, all the other components, but we didn't have a checkbox. So we created one where basically you have a selector for checkbox, check property, and a tap event. And the template itself is just an image where we're binding the source to either unchecked or checked image. And then we just wrap it up nicely in a component. So we have event emitter for a tap event, and then we have checked property. And all of that pretty much means that I can take this checked component and then use it within Angular HTML code. So this checkbox, I'm actually binding checked to a to-do completed element on my page, as well as on tap event to toggle completion, which I think is pretty cool. So what is NativeScript then? NativeScript is an open source framework for building mobile applications with JavaScript and Angular 2. So there are actually two approaches to do that. So one is you can purely just use JavaScript only, or you could use Angular 2. It's just up to you. And the cool thing is that those apps that you're building, they give you 100% native UI for iOS and Android. And we actually have a preview for Windows Universal as well. So what does NativeScript bring into the play? So one of the first things is that you have very rich UI with animations and everything that you can pretty much do on the native layer. And animations that we can run, they actually use the GPU of your phone or your tablet. So we go straight to Android and say, hey, take this component, make it smaller, slide it, make it rotate, all sort of things. Another thing is skill reuse. So if you know CSS, JavaScript, TypeScript, you know Angular, you have your NPM modules, all sort of things, you can reuse that, right? So all of a sudden, you start writing your code in a very similar way as you would do when you build websites, which basically takes us to the point where, oh, that's another thing. And then the other part is basically NativeScript and Angular. You have like, these are first-class citizens of the framework. So it's not something that we just add on and you kind of have to figure out how the two work. It's actually sorted out at the very, very core. And between the two of those, you get a proper NativeScript Angular logo. And pretty much with this combination, we can now target to build Android and iOS applications, and Angular itself will handle websites for you, which is quite cool. Another thing that you get from NativeScript, you have direct access to the native API. So if there is a function or a type that exists at the very, very low level, let's say of Android or iOS SDK, then you can call it. You can call absolutely everything. So you can, and here are two examples. So you can actually call some Android code directly, like go to new android.text.format.time, and that will literally use the Java namespaces that you would have on Android SDK. But the code that you're writing is still JavaScript. So you write native code in JavaScript, which is pretty cool. The thing is that all that code then executes on JavaScript virtual machines. I'm not going to get into too much details on how it works, but that's the idea. But obviously, you don't want to write iOS or Android code specifically all the time, right? It's like, yes, you can do it, and sometimes you might need it, but most of the time you shouldn't need to. So what we have is we have these things called NativeScript modules. And the modules pretty much are the abstraction layer over everything that you might want to use, like be it a camera or something in the UI. So the idea is that you write your code at a JavaScript level. Then you use modules that are there to rule them all, right? And then this translates to either Android or iOS code, which is quite cool. And Windows Universal is coming very soon again. So this works for the UI. So if you, in your HTML, add a little switch, then this will translate to either iOS or Android switch. Or if you want to create a new file object, you just import a file system module, and then you call new file, and then this will give you either Android code or iOS code, depending on which platform you're building the application for, which is quite cool. And there's a whole lot of sets of modules. So this slide is not for you to actually read it all. It's just to show that there's a lot of them, and we keep adding more and more. But that's not the only thing. We actually have quite active community where I think last time I checked, we had like 260 native-specific modules on NPM. And the list is growing. Some of them are UI components. Some of them are just backend components like Firebase. There's one as well. So HTTP module is a very clever one because, and that's very specific as well to our Angular case, where on Android and iOS, there are very different ways of actually calling web services. You can't just make an AJAX call on Android or iOS. So we created this module that actually handles it for you, and it kind of runs in background thread, and the moment when you get the result, it kind of it raises the callback. But for you, it's just that HTTP module. You don't really care how it's done underneath. It's just handled for you, which is quite nice. So the big picture pretty much is at this point, if you use this HTTP module, is that the moment when you build it, you get an implementation that issues either iOS or Android calls, which then does something within your iOS or Android application, yeah? So that's kind of like the NativeScript big picture, right? We say like, yeah, you can do multiple mobile platforms with NativeScript. But then when Angular comes in, is the bigger picture, right? At this point, we have the Angular HTTP module, that is the Angular ones. And the thing is that the XML HTTP request is something that is provided by the browser, right? So in the NativeScript, on the NativeScript side of the story, we provide our own HTTP module, which uses the one that I was showing you. So when you build the application using Angular for mobile with NativeScript, we give you ours. But the moment when you build the application for the website, you get the one that is from your web browser, which then will issue an AJAX call, and then something will happen in your web application, which is really, really cool. And the thing is that you can build your components in that way as well, that are actually not just for website or not just for Android. They could be just for everything. It's perfectly possible. It's not even hard. So all of that pretty much means that within Angular 2 with NativeScript, you can use the standard syntax that you have in Angular 2. So you have property bindings, event bindings. You have pretty much everything. So let's talk a little bit about code sharing. And I'm going to actually do some stuff on the laptop to actually show you how it works in action. So at the moment, there isn't a standard way within Angular that will allow you to have a single project to build mobile and web applications from the same structure. It's not something that is provided out of the box, but there's different ways you can handle that. So the simplest one is build your services. Let's say you could have your user service or your data service or payment service, anything. You can have like the whole service layer, and you can put it in a shared folder. And then later on, when you create your web project or your mobile project, you can basically just copy that folder over or maybe link it across, right? So this is kind of like manual work. It's not ideal, but that's the approach I use quite often. But it works. And the cool thing is that then the shared folder between the two is identical, but where the things differ is where you define what goes into the UI. So the HTML that you have in there, obviously you wouldn't have a div on Android, right? There's no such thing. So you'd have to come up with the Android implementation of the same. Another approach, which is more elegant, is to use Webpack. So you could use Webpack for a single project structure, which can actually allow you to build your application so that when you build it, it will grab the web-specific files and put it into the output, or when you build the application for mobile, it will grab the mobile-specific files and send it to the output. And the files that should be shared, they just remain as they are. And so the way you do it is you have a Webpack config, and then inside there you could specify a loader that basically says, like in this case, replace, if you see tns.html, replace it with web.html. If this is a web project. If it isn't, then leave it as it is. And similarly for CSS files, if you see any CSS files, then rename from TNS to web CSS, which I think it works quite well. The other part of the Webpack config, it allows you to actually go and grab any imports. So if you require any modules, then we look within NativeScript files, find them, and then place the necessary components in the right places. Or like in the second line, we have a CSS loader, so you could pretty much go and use Sass, and what we would do is compile the CSS for you, and then inline inject it into the code, so that it actually you have the CSS that is specific for the mobile application, but as well in the right structure as you need it. So all of that pretty much means that basically using Webpack, you get this naming convention then, where you have either files that are, if you want to make something native specific or web specific, you either call it TNS something or web something. And this is just one example. You can actually come up with your own naming convention, but this is just one of the ways. So let me show you how this whole thing works in action. Cool. Don't need that. Make it bigger. Can you see? Yeah, I should be able to. So I wrote this very simple application, and I'm going to start with how I would build it for web application, for web. So the application is there's an API that allows you to generate avatars, right? And the API has a few services. One of them is if you call HTTPS get API adorable avatars list, it will give you all the possible attributes, right? So it show you what faces, what eyes, what mouth you can put. And so I wrapped it up in a get possible parts function. And then another one is you have to be able to actually then pass in what sort of avatar you want. So I have another function that basically just takes all the attributes and then gives you a URL that generates the avatar for you. So that's the first step. And then, so this sits in my shared folder. So then later on, when I want to do something about it, I can go into and build my avatar component. So in this case, what I do is I import my avatar service, provide as a provider, and then basically I have a whole construct where say, okay, I have all the available eyes, noses, mouths, what's the current selected index of each of those. I have getters in order to retrieve specific value for the selected item. And then in my constructor, I as well go and actually call the avatar service and say, hey, go get possible parts, and when you got them, just assign them to the available eyes, noses, and mouths attribute. And then final function, I have this reload, which basically every time I want to refresh the page, it basically goes and grabs a new avatar. So having done that, then I can go into my template URL where I have my HTML that defines what goes in the UI. And then in here, I pretty much use ng4 with a button. So I'm saying go through all the available eyes, grab them, and then create a button for each. And the same thing I do for noses and mouth. And then each time somebody clicks on an item, I basically set the selected index of that specific property. And as well, I say reload the avatar. Yeah? So I do pretty much for all three of them. And then I have an image that is bound to avatar source. And as well, like a tag that basically displays what it should be bound to. So if I show you in action, let's see if it works. So that's my amazing application. You can see I'm a designer. So by default, we selected eyes, mouth, and mouth. But if I change eyes, nose, and mouth, no, let's find a happy face. Where is it? There you go, that's happy. And a bit smaller nose. Yeah, that's me after not sleeping. And this is me after presentation. And this is the thing, okay, so now we have a website, right? So how do I turn this into a mobile application? Well, it's not actually that hard. So let me hide this. Okay. So for mobile application, let's start from the beginning. I have my shared folder here already. I already copied it over. And I have my avatar service, which is exactly the same file as in the other place. But then let's have a look at the component itself. So I have my avatar component. And you see, actually, all of this, where I say component, the available mouths, selected index for eyes, and all the properties, is actually exactly the same code, right? So what is the difference? Well, the difference actually sits in a template URL. So in here, and let me do it this way. I'll show you, this already rendered the application. Can I make it bigger? That's annoying. Sorry, command 1. Hey, somebody's using it. Oh, now it broke it. There you go. I owe you a T-shirt. Come after the session and you get a T-shirt. All right, so you already have it, you get a second one and a sticker. So here we are. So at the moment, we don't have much here, right? We just have a grid layout with some labels where we print those. So if we were to, and this is the interesting thing, we don't have divs, right? We said the UI in NativeScript is actually different to what you have in a website. So none of those things exist. So if I wanted to now provide the list of eyes and mouths and noses to select from, I'm not going to type all the code, but I can use ng4. So what I'm doing is saying I want to have a label. This label actually looks quite cool. And I'm going through all the eyes and basically printing the text as the selected eyes. And if I save this, this will pretty much use the same service to load all the possible attributes as I had in the web page, and then print them out over here on the right-hand side. So here you go, we have a whole list of them, right? And same thing, I can pretty much then add for noses, and I can add mouth as well. So now we'll have like 3 columns with possible attributes that we can select from. Yeah? And the cool thing is this is still using the same service. There's like that was exactly for the website. So now let's, in order for us to actually show the avatar, what we're gonna do is we need a label that will kind of show the URL that we're trying to display. But as well, we have an image which is bound to the source. And if I save this, we'll have this amazing application. I should publish it, seriously. Well, there's some tweaks that I needed. And now I can actually go and then go and change avatars and play with it. So you see, this is actually a native application that's running. I mean, and we can do some other things. So because we are on the mobile side, we can start using some animations, right? So what you see here already, I have a conditional class CSS statement, where basically I'm saying use class selected if this is the selected item, but use class unselected when it's not. So what I can do is actually I can go to my app CSS. So you remember when I mentioned before that in NativeScript we have native animations. So you see at the moment I just have the selected class, but what I can do is something like this. So let me save this and I'll explain what it does. So what I'm doing is actually saying, so my selected class not only should have the color set to red, but as well, we should be using an animation. And this animation should be animate select. And in this case, I'm saying start with item of this 100% size, but then scale it, make it bigger by 40%, and then scale it back down. And similarly, for the unselected one, I'm actually saying change the opacity to 0.3 and then put it back to visible. So I'm making it slightly transparent and then put it back. So now you see as I click through elements, kind of goes bigger and smaller. And the previously selected item kind of fades at first. And you know, those are native animations. So you can actually start then tweaking and making things look different with different UIs. Cool. So this is how you would build the application when you actually share the code by like copying the files over. The other approach, which was provided to me by my friend Omar from GFT, and he's, by the way, going to run a workshop on how to do this. It's definitely worth attending and voting for. Is that the right project? That's the wrong project. Sorry, just give me a second. There we go. That's the project. So let me start with the Webpack config. So the code I was showing you before is actually were screenshots from here. So it's actually just here where I specify if you want to build for web, go and replace tns.html with web HTML, and same thing for CSS or Sass CSS, which basically then lets me do things like where I have multiple components. So I have my card component, and you see the card component has card.component.ts, which is the shared file and a shared component for both mobile and website. And we have functions like get product, get item total, get total, increase, etc., right? We have all those functions. They're exactly the same for both. But then when I want to define what goes into the UI, this is how the NativeScript HTML will look like, where we use, you know, our stack layout, where we use labels and buttons and all sort of things which are mobile specific. But then when you want to build the same thing for a website, then the HTML is using what you would see normally in a browser. And there's a whole bunch of other components that do the same thing. So you have a checkout, again, one TypeScript component for 2 different HTML files. One more thing I want to show you is, one interesting thing is that the routers, the way you navigate between pages in a mobile application is very different to the way you would do that on a mobile application, right? So we built our own router service, yeah? So if you are in a NativeScript, we actually, you have to import a NativeScript Angular router. So then when you call Bootstrap, for when you kick in off the NativeScript, when you kick in off Angular application for NativeScript, we then pass it in this NS provider router, which comes from the NativeScript packages. But when you build the same project for the website, then you just use the router provided by Angular team, and then you inject it. So again, in order to kick off the project, you have 2 separate files. So that's pretty much it for code I want to show you. Still alive. So if you guys want to learn more, we submitted 3 different workshops for the Angular camp, which is going to be happening over the next 2 days. So there's one that I'll be running with help from GFT actually. So there's one for building mobile applications with iOS and Android. Then there is one that is basically using Webpack to do the single code structure. So just the last part I was showing you that, and that's going to be run by Omar. And then somebody as well proposed building an Angular NativeScript app to control a robot, which should be cool, and I'll be attending that one. I did not have anything to do with preparing it. And then as well, there's an online tutorial. So there's a really cool guide that you could go and try. It takes you to like step by step how to build an application, which is like we call it the grocery app, but it's basically a to-do list or shopping list that you want to do. And it takes you through everything from how you build services, how you call backend services, user management, animation, pretty much everything. A little bit about our timeline. So you can see that we've been going with NativeScript for quite a while. We are into 4th year now. And since we launched NativeScript version 2 at NGConf, we actually did that. Basically, things are actually kicking off a lot. So our growth in terms of adoption is about 30% month on month. So we're definitely going in the right direction. And next year, it's going to be the massive explosion. Everybody will use it, definitely all of you. I mean, I remember all your faces. I'm not kidding. Seriously. We have a very, very nice community. So actually, people who write our tutorials, who wrote NativeScript books and stuff, they're all there. They're actually quite active. So if you want to get started, or even within your company, this is a great resource. Our developers are there quite often as well. So you should definitely join the Slack channel. I'll give you a moment if you want to take a picture. Which is definitely worth checking out. You can check us out on Twitter. We tweet about the important stuff, or if you do something nice, we'll retweet you as well. And yeah, do I have any time for questions? Yeah, any questions? I actually can't see because the light is blinding me. Oh, there's one. Yeah.
That's maybe the first question. What is the real difference in the build process between iOS and Android?
What's the difference between build process?
No, I mean the difference is only the build process, or we need to have different HTML components for both platforms.
I see. Okay, so the question was, what's the difference like in the HTML that you're building between iOS and Android? And this is actually the abstraction layer takes care of this. So like, you remember when I showed you the switch? We have the same thing for label, button, pretty much all the standard UI components. This actually takes care, it will give you the iOS or Android specific component. And the cool thing is, even if you want to use a third-party component, so let's say somebody builds you a native iOS calendar and native Android calendar, you could actually import them, write a small wrapper around it, and it could be one of the tags there. So for you as somebody who's coding it, there is no difference. Like, you don't even have to see that they're actually two different components. Any more? There's one over there. We could wait.
Okay, nice. Do you have any canvas component or something like so to, I don't know, if we want to make a component that draws a plot or a graph or such things?
Yes, we do. Actually, yeah, so that's something that the question's been going on for quite a while. So we started working on it. I think there's still a few things we have to tweak, but there's already something that you can start playing with. But yeah, we should be releasing it as well. Any more? There's a T-shirt for asking about performance. Anyone?
We have still some time, so please feel free and ask your questions.
One last question. There you go. It's done.
I have a question about, is it with all the like different renderers of Angular, can I render in the same app both NativeScript and React Native?
Yeah, why not? You should. I mean, actually, we have a proof of concept where we run React Native within NativeScript.
Oh, that's cool.
That's one thing you can do for sure. But as well, like using the whole code sharing, you could even have two different apps built the same way. Cool. Okay, so no more. There's one last question then. Can I do one last?
Just a moment.
And that'll be the last.
What's the size in megabytes for the demo application of NativeScript?
So I think that for iOS is 6 megabytes that we start with, and for Android we start with 8 megabytes. But actually, it's mainly because like for Android, what we're doing is we pre-packaging a JavaScript virtual machine into the app. And because there's different versions of virtual machine that run on Android 4, 5, and 6, we have to actually pre-package few of them. So if you're actually building, you could actually build the app where you say, this is specifically for this version, this version, this version, and Google Play allows you to do that. Then you could actually publish these apps as much smaller, and then those apps can then shrink to as small as like 2 megabytes. But if you don't do anything, we're looking at 6, 8 megabyte sizes. All right, so in that case, no more questions. All right, thank you very much. Have a good day.